Now that you've begun writing your first SQL statements, you're probably really starting to see just how much data you can pull down from databases. So far, what you've been experimenting with only has been a few thousand records, but many databases have a lot more data in them. Someday you might work with databases with millions or even tens of millions of records in it. It almost boggles the mind, right? Well, clearly, we're never going to want to look at all of that data at once. So thankfully, SQL gives us several methods to pare down and sort our data so we can quickly get the results we want. That's what we're going to discuss in this module. I'm going to introduce you to several methods for filtering data. At the end of this module, you'll know how to use several more clauses and operators, including where, between, in, or, not, like, order by, and group by. In addition, I'm going to tell you about wildcards, which allow us to search for more specific or parts of record, including their disadvantages and advantages, and how we can best use these wildcards. We'll also discuss how to use some basic math operators, as well as aggregate functions like average, count, min, and max. And we'll start to begin analyzing our data. Obviously, this module's jam-packed with new information. So let's not waste any more time and go ahead and get started. So we've learned all about the basics of actually acquiring data from a table using select and from commands. But that's only part of the story, because most of the databases contain thousands or even millions of records. Often we don't want to look at all that data. I know I don't. In this lesson, we're going to go over filtering with SQL. Filtering is extremely important because it allows us to narrow the data we want to retrieve. Filtering is also used when you're doing analysis to get very specific about the data you want to analyze as part of your model. After you've watched this video, you should be able to describe the basics of filtering your data, use the where clause with common operators, use the between clause, and explain the concept of a null value. All right, we have a lot to cover, so let's begin. Filtering SQL is important to understand because we have a couple of options as to where we can filter down our data and get specific. But there's some huge benefits when we're doing it directly with SQL instead of relying on the client application to do it. First of all, when we filter our data down, it will often reduce the number of records we're retrieving. Instead of just going and grabbing a whole table and pulling every column and row from it, we can get really specific about the data we want to obtain from that table. And subsequently, that reduces how much data we're pulling in from the system. Reducing the amount of data you're analyzing will of course speed up the query performance, which in turn will speed up our overall processing. It also helps when we add the filtering at the database level, because this reduces the strain on the client side of the application, which will also allow it to run better. Before you go and pull a whole table into a program like R to start doing analysis, filter that data down before you even pull it means you won't have as much data to churn through when you're analyzing it. Again, we want to try and push as many filters down as possible because databases are really optimized to do this. It also then helps to make sure that we're not straining our client application and ultimately ensures we're getting the data we want and need. To do this, we use what's called the where clause. And the where clause comes after we use our select and from. You have to select your columns and then choose which table you want the columns from. And then you add where along with your column name operator value. There's a couple different operators that you could use. You could use equals, not equals, greater than, less than, greater than or equal to, less than or equal to, between, and is null. We're going to go through a couple applications and examples of each of these operators. In the first example, we're going to filter just on a single condition. For this, again, we have select our product name, our unit price, our supplier IDs, but we want to just look at the suppliers and the unit price for the product name tofu. So after the from, we're going to add where product name equals, and then we enter what we want it to equal. In this case, tofu is a string variable. So we're going to put the string in individual quotes. As you can see, the result is a single line where the product name is tofu. And then we also have the unit price and supplier ID. For that, in this example, if we had multiple records that were named tofu, we would see more rows. But in this example, we happen to just have one record, which is named tofu, so we only see the one row. Another way to do this is to filter on a single value. In the last example, we had a string, so a single condition. But maybe we want to look at products whose prices are greater than or equal to 75. So in this example, we'll take the columns that we're interested in and we'll get the data from the product tables. But this time, we're going to look at the records where the unit price is greater than or equal to 75. As you can see now, we get multiple records retrieved. But if you look at the unit price, all of the records for this unit price is greater than or over a value of 75. One tip I like to do is maybe I didn't actually need the unit price in my data. I just want to filter out those records that are greater than 75. Before I run this, I didn't need to pull in the unit price as one of the columns, but what I like to do is leave it in there to include it just for a little while, just to make sure I'm really getting what I think I'm getting. When you're just starting to write queries and testing them, I would leave in some of the columns for what you're filtering on in there. But if you don't need it, then you definitely don't need to pull it in. Another way we can filter is by looking for non-matches. Maybe you don't have just a list of one product that you want to go after, such as tofu. Maybe you have a whole bunch of products, but you know that you don't want a particular single product or a couple of products. It would be easy just to say, give me everything except blank. Again, we're going to look at products and their prices from different suppliers. But for this query, we don't want to include a specific product name, Ellis Mutton. So basically, we want to pull all records except that. We'll add our operator, in this case, not equals, and then because this is a string value, we'll add those single quotes around the string we want to filter out. What's really handy though is you can filter for a range of values. This is a little bit different because it doesn't have an operator. What it does use is between and. It's still the same format, but this way we can filter in where the units in stock are between 15 and 80. And so it really rolls off the tongue in the way you write it because you're going to put the column in that you're interested in, units in stock, and then between the two numbers that you're looking for. So to do this, I just want to put between 15, and I want to make sure to include and before the next condition. Here you can see I pull in the units in stock, and you can see the result for that are all between 15 and 80. Another example we'll go through is filtering for no value. In this example, what we're doing is filtering for something that is null. It's really important again to remember the difference between nulls and zeros. A null is very different than having a price that is 0. A null means that there is actually no data in this column. If you want to look at something where you know the price is 0 or it is an empty string, then you need to type that in as your condition. If you want to look for something where there is just no information for that column, that's where you would want to simply use is null. Here we're going to use where the product name is null. Maybe we're doing some profiling of our data and we want to see, are there any records missing from this column? This is a great way just to check and see, does the column representing the product names have some type of information for every record? So for this query, I'm asking for the records that have null value of the product name. Because I get no values returned with this search, that means that all the product names have some value in them. Again, remember the difference between null and where there is actually a 0 or an empty string. All right, so in conclusion, remember the different operators that we have for this. Equals, not equals, greater than, less than, greater than or equal to, less than or equal to, along with between and is null. Remember also to always use your where clause and then feel free to get creative. This is something I really think forms the backbone of many SQL statements. For many queries, you'll have the select from, and then more often than not, you'll be filtering down with the where clause in some regard to limit the number of records returned. Welcome! In this video, we're going to build off the last one and we're going to go over some more advanced filtering techniques. If you've already tried out some of the operators in the last lesson, you'll understand that they're very powerful and you can do a lot with them. We're just going to expand on those in a little bit by going over the in, or, and not operators. After this lesson, you'll be able to use the in and or operators in detail to filter out your data and get the results you want, differentiate between the use of the in and between operators, discuss the importance of the order of operation when using these operators, and explain how and when to use the not operator. Okay, first let's discuss in. To use the in operator, what we're going to do is specify a range of conditions. This is similar to between, where you could say it's between two variables. You can also do a very specific number of conditions and have additional conditions. To do this, you're going to enclose your values in parentheses, and you're going to have a comma-delimited list of values. In this example, what we're going to do is look for suppliers, but we want an individual list of this. We only want suppliers 9, 10, and 11. Another example would be to have suppliers maybe 1, 5, and 10. This is something where between wouldn't have been helpful because we aren't looking for a range of values, we're looking for specific values. In this example, we'll go with our select statement, where we're getting it from, and we'll add where supplier ID is in, and we'll indicate the values 9, 10, and 11 in this example. You can also add string values, but just remember, those have to be added in with single quotes to indicate that they are string values. As you can see by the results returned, what we have is a product ID, the unit price for those products, but we've limited our results to the suppliers that are 9, 10, and 11. Another operator is the or operator. An important thing to know about this is that a database management system will not evaluate the second condition if the first condition is met. So you're not going to want to use this for something when you want to check for both of the values. Remember that you would want to use and in that instance. For this example, you're using product name. I want to make sure that I am very specific that I want tofu over kombu, because once it finds tofu, it's not going to give me the other product names. This is really helpful if this is indeed what you want. But if not, just be really specific about the order that you're placing the items in your query. You may be thinking, though, that in and or can accomplish the same thing. And they can, depending on how things are written. I couldn't have written this instead having said where product name equals tofu or kombu. Or if I wanted both of them, to choose where product name in and then in parentheses lists the two values. But there are some benefits to using one versus the other. If you're using in gives you a lot more options in how many things you can list. Within, you can list multiple things. I could have listed 10 different product names and brought it all back. Or it's just going to give me 2. And in actually executes faster than or. So that's another benefit to using in. Within, you don't have to think about the order in which you're placing your different conditions. And another benefit, and probably the main benefit of using in, is that we can use another select statement for subqueries, which is something we'll go over in a later lesson. But just keep this in the back of your mind for now. Another thing you can use with or, though, is and. I want to go through this a little bit more detail, because you may get some different results if you're not careful. In this example, what I'm looking for is products where I have a specific group of suppliers, but I also have a specific unit price I want it to be above as well. I could write it as I did in the first example. I have my select statement, and I have where it's from. And I have where supplier ID equals 9 or equals 11. And I also add the unit price is greater than 15. What you'll notice though is I'm getting some unit prices that are not greater than 15. And so one of the things to understand about why this is happening is because SQL is processing the or before the and. And so one of the ways to limit this is to use parentheses. In the next example, you can see I have the same exact statement and query, except I place parentheses around supplier ID and then have and unit price. Now you can see I'm actually getting all the values I'm wanting. All my unit prices are greater than 15 and my supplier ID are just those of 9 and 11. An important thing to understand here is just the order of operations when using and the or operators. You don't have to use the parentheses, but it's always really good just to get in the habit of doing it. This way you're not relying on the default order of operations, but you really can never be too sure. So I would recommend to just get in the habit of using the parentheses when using or and together. The last thing we're going to go over for filtering is the not operator. This is just a way to exclude different options. Again, this is a great way when you want pretty much everything, but there's maybe just a few variables you don't want. So in this example, I'm looking for different employees, but I don't want any one of the employees who are from London or Seattle. So to do this, I'll just put where not city equals London and then not city equals Seattle. Again, using single quotes to denote the strings London and Seattle. And as you can see in our results, it returned everything except for those two cities that I had specified not to include. So in this video, we've gone over using the in, or, and the not operators. Remember, with in and or, you can accomplish some of the same things, but there are some benefits to using in versus or in certain cases. Again, if you're using or and together, really be careful of your order of operations and use parentheses. And use of the not is pretty straightforward. So just keep that in your toolbox as you're thinking through your query designs. Have you ever come across data where you knew either the beginning or end of something, but didn't know the rest of it? Or maybe you know that something is like something else, but slightly different. Well, in continuing our discussion with filtering in this module, we're going to take the next step and discuss the use of the wildcards and the like operator. After this video lesson, you should be able to explain the concept of wildcards, including their advantages and disadvantages when they are useful. Describe how to use the like operator with wildcards, and write out the appropriate syntax when using wildcards. All right, so the use of wildcards is a really powerful technique, especially when it comes to string values or text data. As data scientists, we often analyze these values or maybe just pull a portion of the information from a column or field. Wildcards get used frequently when doing different types of analysis and retrieving your data. A wildcard is a special character used to match parts of a value. What you're doing is searching for a pattern made up of literal text. You know, the beginning of a phrase, ending of a phrase, and you're able to pull data for that based on your search conditions. One of the things you'll use, though, with this is the like operator. Like is actually technically a predicate, not an operator, but oftentimes it just gets referred to as an operator, so that's what we'll refer to as here. A thing to know with a like is that it can be used for string variables and non-text data types. So these wildcards cannot be used for numerical data. Again, though, this is really helpful for data scientists as you're working with strings and you're working with text data, because at some point you'll probably want to do some text analysis and you'll want to pare down the columns or the data you're retrieving in an easy way. Wildcards allow you to do just this. To use the wildcard, what you'll do is add a percent sign before, after, or in the middle of what you're searching for. So I love pizza. I'm always looking for good pizza. So maybe in my data set, I want to find things with the word pizza in it. There's a lot of ways I can search for this. If I add the wildcard before the word pizza, I'm going to find anything or any phrase that ends with the word pizza. If I add the wildcard after the word pizza, it's going to grab anything after the word pizza. So I'm just pizza crazy and want pizza in the middle of everything. Then I'll add the wildcards on both sides of the word. Wildcards become helpful because a lot of times you'll see data that has just a whole string of information in it. In the Northwind database, some of the product descriptions will tell you how many ounces a unit holds, and then it goes on to tell you how many packages are in the box. But maybe you just want to know the word package or box from the list of the string variables. This is a really great way to start to parse out that information and that may be hard to retrieve. It can also help in decluttering things or just doing a general overall search. Another way you can use a wildcard is in the middle of two letters. I may search for something that starts with S and ends with E. And this then, in turn, would grab my name, Sadie, because my name starts with S and ends with E. It's not common, but may be helpful if you're looking for, say, different emails. In this example, I'm looking for maybe somebody whose emails are Tom, or I'm just interested in all the emails that start with T. I'm going to put T, then I'm going to put my wildcard. And maybe I'm particularly interested in those emails that are at gmail.com. And these records, I'm specifically searching for all Gmail addresses. And so this is one example where you would use a wildcard right in the middle, where it starts with a phrase and ends with a phrase. It's important to note that the wildcards will not match null values. Again, remember nulls are really no value in the column. You wouldn't be able to use a wildcard in those cases. Some of the ways you use wildcards, and I won't go into too much detail here because it really depends on your relational database management system. But you can use wildcards with underscores. In this example, we're going to have where size is like and then underscore pizza. This is going to produce an output where it ends in the word pizza and then it brings everything before that. This isn't supported by DB2, which is a pretty popular system, but I think it's important to note because most other systems support it. You can do it in another example where you just have your wildcard pizza and it's going to produce the same results. Another one is to use brackets to specify a character in a specific location within a string. I won't go into a lot of detail about this because in this class we're using SQLite and brackets used in this manner are not supported by SQLite. But just be aware that there are different ways to use wildcards in different database management systems. Again, it's really important to rely on your relational database management system and what wildcards it uses. But again, the concept behind wildcards are all the same in all systems. Now, there are some downsides to using wildcards. One, queries using wildcards take a little bit longer to run. If you can use another operator such as equals, greater than, or less than to achieve your same results, you'll get a lot better performance out of your system. However, wildcards are really helpful because they can help you find a wider range of things, such as with a phrase that ends in something or starts with something. Sometimes they're the only option you have, but if it is possible, use another operator. And finally, be careful on where you're putting your wildcards. Just remember that I always recommend when you're starting a new query to start slow, build upon it, and do some simple testing before you add it into your larger query. Okay, so we've gone over a whole bunch of techniques for getting data and filtering it down to what we're looking for. But have you noticed anything? There's no logical order to that data. It's just returned in the same order it was entered or captured in the database to begin with. It's not in any numerical order or sorting, ascending or descending according to the alphabet. It's essentially presented in a random order. Well, in this lesson, we're going to bring some order to that chaos by going over the order by clause to sort out our data. So this is a really simple concept, but as you'll see with most things in SQL, they're pretty simple concepts, but they're really powerful when you add them together. These little tips and tricks that you use when you're writing your queries or looking at your data, just simple things like being able to sort your data, can really help you understand the results and what you're getting back. So after this lesson, you should be able to discuss the importance of sorting data for analysis purposes, explain some of the rules related to using the order by clause, and actually use the order by clause to sort data either in ascending or descending order. All right, so let's begin. So to sort data with SQL, we use the order by clause. Sorting data in a particular way can be really helpful when viewing data. Otherwise, our data could be returned in a manner which makes it a bit more difficult to interpret. Data in tables is not usually consistently ordered, as the data can be updated, deleted, or changed at any point. A lot of times, you really can't rely on the data being returned in any logical order. So if you really want to look at your data in a particular order, it's always good to be specific about the order you want it to be in. The other thing is, a lot of times when you're looking at data, you're not going to be able to look at all the records. The other thing is, a lot of times when you are looking at data, you're not going to be able to look at all the records. Sorting your data in a logical fashion can help you easily look at the information that you want on top. It's really helpful to be specific always about your data that you're retrieving, but also about how you want to do that. Order by allows us to sort data by particular columns. Now, there are a few rules when using order by. One is that it can take multiple column names. You can order by one column or can order by all the columns, and so it goes in the fashion that you want it to add them in. If you're doing multiple columns, you just want to make sure you're adding a comma after that. The other thing is you can actually do is sort by a column that you didn't retrieve. So it may not be in your select statement, but you can still use the column to sort your data, which is really helpful. The last rule is that order by must always be the last clause in the select statement. Just kind of on the finishing touches, always round it up with the adding the order by at the end. So to do this, you can sort by column position. Here at the end of my query, I have order by columns 2 and 3 in the table. Or you can even just sort it by the actual names of the column. I usually just do the names of the columns, and that keeps things really consistent. If I'm looking at my products table and sort it by the products' names and then by their unit price, then I would just add that in order by product names, comma, unit price. There are also some directions, as with any type of sorting, so you can sort it either in ascending, ASC, or descending order, DESC. And then this is only applied to the column name it directly precedes. If you're using order by descending and have unit price, it's not going to do it for all of the columns after the descending. You have to specify each individual columns for ascending and descending if you want it that way. So again, the idea of ordering is a pretty simple concept here. But as you can see, it's really helpful in just making sure that when you're retrieving your data, you're viewing it how you want to view it, and really just getting to the core of those results. So I highly recommend and encourage you to explore and use order by to help you make sense of all the data that you're analyzing. So I hope you've enjoyed what we've talked about so far in this course, getting data, filtering data, and so forth. But as you're probably aware, there's so much more we can actually do with our data. In this video, we're going to go over using basic math calculations with our data. After this video, you should be able to perform basic math calculations using your data, discuss in more detail the concept of the order of operations, and describe what can be done in terms of analysis by using math operators and SQL together. With math calculations, we're now getting into some techniques we can use in analysis. but also be able to use these in SQL and be able to push them down to the database. As we've talked about in so many cases, the more we can push down to the database and have the processing power of the database, the better. Again, we're usually working with larger amounts of data, so we really want to reduce that strain on the client application. The closer we can do this to the source, the better we'll be in the long run. So we'll just start with some simple ones. We have the addition, subtraction, multiplication, and division. As you can see on the left-hand side, we have your standard operators for this. In this example, what I want to do is I want to get the total units on an order, and I want to have that times by the units price to get the total order cost. What I'll do is I'll treat this just as I would any other column that I'm retrieving. Here I have my select. I have the different columns that I'm interested in. I have my product IDs, units on the order, and unit price. And then I list out just as I would in any column, but I add in my operators. Here I have my units and order times unit price. And then I'm using an alias as for what I want this new column to be named, and this is going to be the total order cost. And then I'm going to state where I want it from. As you can see, I now can retrieve 4 different columns: the product ID, the units on the order, the unit price, and then my new calculated column, which is the total order cost. Again, I like to bring in those other filters when I'm first calculating something, just to do a few spot checks to make sure my calculations are correct. I don't need to have the unit price and the units on the order. I could have just selected the product ID and then calculated the new field. This is just a nice little thing I like to do when I'm creating a new calculation to make sure it all adds up and looks right. In another example, you can start to add these operators together. And just with any math you're doing, it's going to follow your normal order of operations. You'll probably remember the order of operations from math classes you've taken in the past. The idea that things in parentheses are handled first, then powers or exponents, multiplication, division, addition, and subtraction. In the United States, the popular mnemonic device, "Please excuse my dear Aunt Sally," is often used. So for this example, I'm now just going to combine division with subtraction. In parentheses, I'm just going to put what operator I want to happen first. For this, I have my unit price minus my discount divided by the quantity. And they have that listed as my total cost. Again, it just follows the same rules. You just want to list your operators in that new field calculation as you would for any other column that you're retrieving. So these are pretty simple examples, but again, really powerful when you start to add these together. Just be careful of your order of operation. Then if it's a new calculation you're doing, I would pull in the other fields in the beginning just to double check that the calculation and that you can go ahead and remove those fields later as you build your query. But it's always good to perform a safety check and make sure you're getting the results you really want. Are we having fun yet? I know I am, but it's going to get even more fun in this lesson because it's time to really take a deep dive into data analysis by going over some of the aggregate functions found in SQL. Aggregate functions provide various ways to summarize your data, which in turn really helps you to analyze your data and see what you have. In this lesson, you'll learn how to describe the various aggregate functions and what they do, explain how each of the aggregate functions can help you analyze data, use various aggregate functions including average, count, min, max, and sum to summarize and analyze data, and describe the use of distinct function and how it can be useful. Aggregate functions are used for all sorts of things, and they can be really helpful in finding the highest or lowest values, total number of records, average value, etc. It really builds off of some of those math operators that we have previously talked about, except they're just pre-built-in functions, so it makes it super easy to start to aggregate and summarize some of your data. A lot of times in descriptive statistics, we are getting to know and understand our data. We're going to use a lot of these different types of aggregate functions. The aggregate functions we can use are average, count, min, max, and sum. And all of these are pretty self-explanatory, as you can get the average of column values, count the number of values, find the minimum and maximum value in a column, and then sum the total column values. In this example, for average, we'll use our select statement. And then just as we would list out our columns that we want to retrieve, you're going to list it out as a column you want to retrieve. But before you put your column, you're going to go in and add the function that you want. In this case, I have average because I want the average unit price. For this statement, I'm also going to add my alias to rename this column because I'm not just going to pull in the unit price. It's now the average of the unit price, and this is from the products table. Something to note here is that rows containing no or null values will be ignored by the average function. Moving on, the count function is really helpful when we want to get an idea of the contents of a table. This is just helpful to understand how many records are in a table, or how many records contain information. If you do a count with a star and brackets, you're going to count all of the rows in a table. And this could be all the values or no values because this is just counting any row in a table. You could also then count an individual column, just by selecting count and then the column name. This will then count the rows for that specific column and would ignore the null values. Below we have two different examples, one where we're looking for all the records from the customer table, and then one where we're just counting the customer IDs from the customers table. Here we may get the same results or we may get different results if there are no values in the customer ID column. Just kind of a note the differences there. You, of course, could just count one of the columns to get an overall view of the table, but then you're missing out on any null values that might not be giving you a clear picture of the full table. If you really want an overview of the table, use the select star count. Okay, another aggregate function we have is the min and max. This is really great. Again, you're starting to understand your data. You just got a new table. You want to see what some of this data looks like. It's always great to get a range of your data. Pulling something like what's the minimum value, what's the maximum value, starts to give you an idea of what are the distributions. And there are potential really high outliers in this data. And all of this can be done on the database. It's really helpful to do this if possible. To use this properly, we're going to put our function in a parentheses. We're going to put the column that we want it to work on, so we have select max unit price. I always do an alias because otherwise the column name will just come through as blank. And so it's helpful to remember what I was actually trying to do here. Another thing to note is that again the null values will be ignored with the min and max functions. If you are just using this function, just be aware that when the null values are ignored and when they aren't. Finally, we have the sum aggregate function. Again, you can use this in a similar fashion as with the other aggregate functions. Go ahead and state sum, the column that you want to sum, and what you want it named as, and then where you want it from. For this, we can also add these together with some of your math calculation functions. For this example, I want to look at the unit price and units in stock. I want to get a total for that, but I also want to add all of those together. Now I have the total price for all of the products with the unit price and the units in stock. Now you can see how with the math operators and some of these aggregate functions, you can really start to get a better understanding of your data and now even start to do some analysis and enter your own data. Before we conclude, I want to go over one more important thing to use with aggregate functions, which is the word distinct. If the word distinct isn't specific in a statement, SQL will always assume you want all the data. For example, you may have a customer who's in a table multiple times. If you're simply doing a count on your customer IDs and you don't distinguish to count just the distinct customer IDs, you may be getting duplicate records in there. And this is really helpful to run queries where you're counting distinct and to see where there even might be some potential duplicates in a column. There are some things to keep in mind when using distinct with our aggregate function of count. You can't use distinct on the count function with the star. Just keep this in mind, not only for when and where you can use distinct, but also to think through when you want to use distinct and when you don't. Again, you're usually trying to understand your data before you're analyzing it. So performing some of these sorts of queries using aggregate functions will help you figure out what you're dealing with in a database. Congratulations! You are almost at the end of this module. We've gone over a lot of great information that not only will help you filter down your data and be really specific about what you're trying to retrieve, but also trying to perform some calculations and some aggregate functions on your data. In our previous video, we went over using aggregate functions such as average, min, max, and sum. However, one of the things we didn't go over is what you are actually aggregating those functions on. In all the examples we previously went through, what we had seen was how to pull a single field and aggregate on the single field. Well, this is helpful. A lot of times we'll be looking at the total price for something, and we may want to look at it for customers or for products, and we need to choose how we're going to aggregate that function. That's what this video is about. And after this lesson, you'll be able to perform some additional aggregations using group by and having clause, discuss how nulls are or aren't affected by the group by and having clauses, and how to use the group by and order by clauses together to better sort your data. Okay, let's start off with a grouping example. Let's say for this example, we want to know the number of customers we have, but we want to know this by each region. In the last lesson, we went over how to count customer IDs and to see our total number of customers. But now what we're going to do is add in that region portion. If we were to just have our select statement with select region, and then we have our aggregate function count customer IDs as total customers, from the customers table, we're going to get an error return because we haven't specified, okay, how do you want me to count the customer IDs? That's where we add in this group by clause. We have now, after this from, we put the group by clause and what we want it to group it by. Some important things to note about the group bys is we can group it by multiple columns. We may have more columns than just region. For example, maybe we want to know region, city, country. We can list all of those in our group by clause. We will just add a comma after every column that we want listed. One of the things to note that's really important is all of the fields that you're pulling in with the aggregate function need to be in your group by clause except for the aggregated calculation. Even though you may only want to group by that region, it's going to need to be summarized by all the other columns as well. So make sure you're listing those out in order. Another thing to note is you have nulls in one of your categories, such as your region. Let's say you have the regions of California, Idaho, Texas, Nebraska, but then you also have some of the other regions that are blank. They have no values. Null will actually be grouped as its own category then. This is helpful because it helps you make sure that you're not missing any data. But it's just something to watch out for and look out for. Now that we've started to use aggregate functions and started to group them, it's also important to know how filtering with the where clause works for some of these aggregates. Where does not work for groups because it filters on rows. Therefore, we have to use the having clause when filtering with an aggregate function and grouping them. In this example, we want the count of orders for customers, but we only want to see the total orders for the customers who have had more than 2 orders. So to do this, we're going to select our customer IDs. Then we're going to count all of the records as orders. We're going to get this from our orders table. And then since we want to look at this by each individual customer, we're going to group it by our customer ID. Then to be able to make sure we're only selecting those customers who had orders greater than or equal to 2, we'll place our having clause of having count greater than or equal to 2. Again, just remember that where filters before the data is grouped and then having filters after the data is grouped. Rows will be eliminated by the where clause, and then those won't be included in the group by clause. This is just important to know when you should use where versus having. Both are very powerful. Both have different purposes. Just be sure to note when one is appropriate so you're not missing any data that should be counted. Another thing to note when you're working with group bys is that it's always good practice to use the order by clause. The group by does not sort the data in any fashion. It only groups it together. In our previous examples, we have a list of states, a list of regions. It's not going to sort those regions in alphabetical order. It's just going to group them by different regions. I always recommend using an order by in this sort of situation. It just makes it a little bit easier to read through your data. It's just good practice to get into. Welcome back, and congratulations! You're finished with this module. We've really talked about a lot of different things in regards to filtering down our data, being specific about what we are after. We've also started to look at some math functions, some aggregate functions, and some calculations. And then we're wrapping up by thinking about how to group your data and filter it out. Now you have a lot of great statements at your disposal, and you can really use these to write some powerful queries. As you start to write more and more complex queries, always be sure to test out along the way, especially as you're doing some of these aggregates in the beginning. Test to see how many records you had before and then how many records you had after you're done aggregating. Really make sure that you're understanding what you're doing. In SQL, it's very easy to get results. So just because you can get data back doesn't mean it's the data you intended to get to, right? Just remember some of the pointers to why we filter in SQL before we obtain the data versus filtering out on the client application. Again, a lot of times we're doing this to increase our performance, so we're not processing through as much data on the client side. But it also then helps us to understand our data, getting really specific about the values that we're looking for, finding a range of values, finding blank values. This helps us in our descriptive statistics. Some of those aggregate functions, such as looking at the min, max of things, and this can really help us understand our data and what's going on. Now that you have learned a few different clauses that you can use with your select statement, I think it's good just to keep in reference the formal structure of it. Prior to this, we talked about selecting data and getting it from somewhere. Now we've added up a couple different clauses, and it's important to remember the order that these go in. And I've just listed these out in order here, starting with the select. So again, we're always going to have that select statement at the beginning. We're going to say where we're getting it from, and then we're going to be using our where clause if we need to do any row level filtering. Again, if we have an aggregate function in our select statement, we'll want to make sure we're including that group by clause. Then, if we have the group by, we may want to do some grouping and level filtering. So we'll be needing that having clause. Order by is always our last thing that we put in our query. And this is just going to sort the order of things in any way that you determine. You can see on the right-hand side, I've listed out whether or not the statement is required. Some of these you can see they aren't always required. This just gives you a really nice structured outline for a lot of the common statements and clauses you'll be using and the order that they should be in when writing SQL statements. Now at this point, you should have plenty to get you started. I hope you have a lot of fun playing around with some of these different aggregate functions, filtering down your data, and seeing how it changes. All right, go out there and give it a try.
Thank you for watching our video. We hope you found it helpful. If you enjoyed this video, please hit the like button below and subscribe to our channel for more videos like this. If you know someone who could benefit from this information, please share it with them. We would love to hear your thoughts on this learning course, so please leave a comment below. Thanks again for watching, and we'll see you in the next video.